Let's find the interval convergence for the following series. We have a sum from n equals 1 to infinity, negative 1 to the n plus 1 times x minus 3 to the n all over n times 3 to the n. So here we're going to use the ratio test. We want to look at the n plus first term over the nth term. So we're going to replace for every n plus 1. Okay, so this will be the n plus first term. Then we have to divide it by the nth term, which is the original sum here. So take the absolute value and take the limit as n approaches infinity. We want this to be less than 1 because that's when the that's when the series converges by the ratio test. Now, because we're taking the absolute value, these negative 1s to the n plus 1 and n plus 2 are just become 1. So we just get rid of those. Those don't really matter. And now we can just group things together. So we can group the first and the last. So it'll be x minus 3 to the n plus 1 times n times 3 to the n. Then we're going to divide that by the two middle ones. So here, you want to put in the correct order. So I can choose to put n plus 1 or 3 to the n plus 1 or x minus 3 to the n. I'm going to put x minus 3 to the n to line it up with the x minus 3 to the n plus 1. Then I'm going to have my n term, which is n plus 1, and then the 3 to the n plus 1. So I'll be taking this limit as n approaches infinity. I want that to be less than 1. Okay, now we can simplify. We have x minus 3 to the n plus 1, x minus 3 to the n. That's just going to be a factor of x minus 3. And then 3 to the n with 3 to the n plus 1 is just going to give me a factor of 3 in the denominator. So I'm just going to have x minus 3 times n over n plus 1 times 3. I can get rid of the absolute value once I have the x minus 3 out of the way. So I'm going to do that right now. I'm going to get the x minus 3. Because it does not depend on n, you can pull this thing out like this. And I can also pull out the 3 as well. So we'll have x minus 3 over 3. You can have the 3 in the absolute value, but I mean the absolute value of 3 is just 3, so who cares? And then you have the limit as n approaches infinity of n over n plus 1 less than 1. We know that this is going to equal 1. So it's x minus 3 over 3 is less than 1, which means that the absolute value of x minus 3 has to be less than 3. That means x minus 3 has to be between negative 3 and 3. So x is between 0 and 6. Okay, so we found this interval, but we still have to test the endpoints. So we want to test when x is 0 and 6. So first we'll be looking at x equals 0. So let's plug that in for x. We have negative 1 to the n plus 1, and then 0 minus 3 to the n over n times 3 to the n. So I can rewrite negative 3 to the n over 3 to the n as just negative 3 over 3 to the n, which is just negative 1 to the n. So then I'm going to multiply that with negative 1 to the n plus 1. They have the same base, so you're just going to add the exponents. So this is just negative 1 to the 2n times negative 1 to the first power. Negative 1 to the 2n, well, that's just going to be 1, since the exponent is going to be even. And then you're just left with a negative 1. Okay, so that's just -1 over n. And then the sum from n equals 1 to infinity. We know that this diverges by the p-test. So we do not want to include 0. Okay, the last thing is to test 6. So you have the sum. And instead of x minus 3, we're going to have 6 minus 3, which that would just be 3 to the n. So now I notice that the denominator and numerator have a factor of 3 to the n. That's going to go away. And this is an alternating series now, which we have to use the alternating series test. So we want to make sure that a sub n is positive, decreasing, and goes to 0. A sub n is just going to be 1 over n. That's obviously positive, obviously decreasing, and obviously the limit goes to 0. All three conditions are met. Therefore, this is going to converge by the alternating series test. So going back to our interval, we want to make sure to include 6. So this is our answer.